So we're now going to make a histogram. And a histogram is a graph that shows the distribution of data. So it will let you see, like, oh, how did the kids do on the test? Were the scores generally high? Were the scores generally low? So we're going to go through the steps to make a histogram. Okay? The first step in making a histogram is to determine the bin size. So, like, for example, you may want to know how many kids scored between 75 and 79. Okay? Your bin score, the number of the range, needs to stay the same. So I'm going to use a bin size of 4. Okay? So if I go back to my data, from that I ordered from Greatest to Leaders, I'm going to start at 65 for my bin size. So that's my lowest score. Okay? So on your x-axis goes the bin sizes. So one bin size, for example, is 65, and it's 4 to 69. So that's one bin size. Okay? It's a bin size of 4. And then, so then the next number would be 70 to 74. And this is a range. Okay? And the bars are going to be about this big. You'll see. And in histograms, you don't leave spaces. Then the next range, again, I'm adding 4, would be 75 to 79. The next range would be 80 to 84. The next range would be 85, that doesn't look like 85, to 89. The next range would be 90 to 94. And the last and final range would be 95 to 99. Because you can't get higher than 100. There's no one with 100. So those are the bin sizes. You could have picked a bin size of 2 if you wanted, or a bin size of 3. Okay? Now we need to find out how many scores are within the bin. So on the y-axis, if you remember, we have scores. So we have, like, percentages gotten on test. Those are bin sizes. Okay? And then on the y-axis, okay, we're going to put the number of students. Or if it wasn't test, it might be like number of monkeys. If you were looking at like the length of their, the length of their tail or something like that. Okay. So we go back to the data, and we have to find how many scores are within 65 and 69. So we go back. We see that there are 3 scores between 65 and there's these. So we're going to go back. And this is annoying to flip back and forth. And I'm actually going to zoom out a little bit because this is hard to do with this large of a zoom. Okay. And so I said there were 3, I believe. Yep. So I'm going to space this out a little bit like this. 1, 2, 3, 4, 5, 6, 7. I think that's enough. And there's 3, so I'm going to make a bar that's 3 in length. And let me scroll down a little bit so you can see the whole thing. Okay, now I need to go back and see how many scores were between 70 and 74. And if I go back, I see that there's only 1 score between 70 and 74. So I'm going to make a bin of size 1. And then if I go back to the scores, there's actually a lot between 75 and 79. I think if I did this already, so if I counted, I think there were 9. Yep, 9. No, sorry, not 9, 7. So I'm going to make a bar that is length of 7. Because there are 7 within that bin, and that is not straight at all. That's great. There we go. And then between the bin range of 80 and 84, if we go back to the data, between 80 and 84, there is 0 between 80 and 84, so there's no bar there. There's no between 80 and 84. The next bin range was 85 to 89, and I believe there are 2. Yes, 2. Right here, 80. So if we go back and put a range 2. Here, so there was none of that. There's 2 here. And I finished it off between 90 and 94. There were 4 scores in that bin. And in the last bin, there was 1 score. And that is our histogram, which shows the number of scores in each bin. And again, you could have made the bin sizes different, and then you have different size bars. Now, most of the time, there was only 1 year I saw in the AP exam where they made you do a histogram. A lot of times they give you a histogram and you have to interpret it. Okay? But just in case they make us do a histogram, this is how you do one. For the homework, you're going to have to do one with leaves. Really, the hardest thing is choosing the bin size. And once you choose the bin size, it actually becomes easier to do. The last thing we have to talk about is standard deviation. We actually already talked a little bit about standard deviation, but it's going to come back when we're looking at natural selection. So we need to bring it back again. So if you remember, standard deviation, okay, tells you how spread out the data is. Okay? The bigger the standard deviation, the more spread out the data. So if we take a look at these two number sets at the bottom, okay, there's 5 numbers in each, okay, and if you look at the spread, this one is obviously more spread out, right? These numbers are really, really close together, and these are really far apart, and they're not as close together. So you will never have to use the formula that's on that sheet to calculate the standard deviation. Like this formula here, they're never going to have you use it, okay? They'll usually give you the standard deviation, which is good, right? So if we go on the homework, it tells you to go to this website, which is here, and the address is on the homework. And you type in the numbers. So I'm going to type in the numbers of the first data set. And it will give you the standard deviation for the set. Calculate. And you see there are 2 standard deviations. There's the sample standard deviation and the population standard deviation. The formula that we have is for the population standard deviation. You would use this, for the sample, the one that we have on the AP exam is for the sample standard deviation. You use sample when you don't have everyone in the population. So like, for example, if you were trying to find like the average height of humans at Pathways, okay, you would only use the population standard deviation if you measured everyone's height at Pathways. If you're just taking a sample of the population, it'd be like 10% of 10th graders, 10% of 11th graders, 10% of 12th graders, and 10% of freshmen. Then you're taking a sample, you would use the sample standard deviation. Most of the time in biology, you're not going to be able to sample the entire population. So you usually use the sample standard deviation. And we see that the sample standard deviation for that set of data is 0.89. I'm going to go back to my thing and do that. So 0.89. And I did the same thing. I typed the numbers into for this, and the standard deviation for this was 0.396, which is much, 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 much bigger than the other one, obviously, because the numbers are more spread out. So again, standard deviation is a measure of spread. The bigger the standard deviation, the more spread out the data is. With the more, now relating this to evolution, the more variation there is in the population, right? The bigger the standard deviation, the more variation there is in the population. Now, I also took the mean of this. The mean of this is 10.6. And the mean of this is 11. And just for fun, I'm going to find the median just to show you how to do it again, because I want you to do well in the SAT, right? So there are 5 scores here, and this is the middle score because there are 2 above it and 2 below it. So in the median here is 10, and you can do the same thing for that data set if you want. But in this case, it's an odd number of scores, so you don't have that case where there are 2 in the middle. If you want to talk about mean, how to calculate median for the SAT, come see me. Okay. So now, most of the time, this is a little bit beyond the scope of AP Bio, but since none of you have taken statistics, I want to show you this. This is a standard curve, okay? A standard bell curve, okay? Standard bell curves are when the mean and mode and median are all equal. Okay, so let's say, like for example, if this is a standard bell curve, the median is at the top of it. Sorry, not the median. The median, mode, and are at the top of it. So this is close to standard. These are close to each other. So the mean is right here. What the standard deviation does, if you add and subtract one standard deviation from the mean, so if you added 0.89 and subtracted 0.89, and let me do that. So I'm going to add 0.89 to this, to the 10.6. So I'm adding 0.89. And I get 11.49, and I'm going to subtract 0.89. And I'm making mistakes, because I'm tired. And we get 9.71. Okay, if you add and subtract the standard deviation from the mean, okay, and within this range, 9.71 to 11.49, okay, that concludes, if we add the 2 percentages, move this thing away, that includes about 68.2% of the data. So 68.2% of the data is in this range. Okay? I have never seen the AP exam talk about that in that way. And if you added another standard deviation, you get even more percentage of the data. So now it's whatever 13.6 plus 34.1 plus 34.1 plus 13.6 is. For the homework, you don't need to be able to deal with a standard curve. But the homework asks you to calculate the mean, median, mode for a set of data. And it tells you to get the histogram from a website. I'm sorry, the histogram. The standard deviation from a website. And then the other thing you have to calculate, which I'm going to put the link in the description of the video that you have to remember or go back to your notes and remember how to calculate standard error of the mean. So that's what the homework asks you to do. On Tuesday, I am literally going to be here bored to death. If you have questions, you need to ask them. Alright? So I will see you guys again on Wednesday. Have a good 4-day weekend. Goodbye.